Better.
Okay, so today's class, by the way, you are in AP Computer Science, A with Java, and we are doing Mr. Lee's, my favorite lesson plan. This is called the Build Peanut Butter and Jelly Sandwich, and it's all about understanding or discovering what an algorithm is and what pseudocode is. So if you guys could pan to my, those are my freshmen up on the overhead projector. So they're talking about basically our essential questions for the day. What is an algorithm and what is pseudocode? So, Caroline, what's an algorithm? That's a good question. Would you like to phone a friend?
Yes, I would.
Okay, then you need to phone. Awesome, George. You're going to have to wait.
Okay.
We will do the robotics thing. You can zoom in on the robotics because we're going to do a shout out to the robotics club today. But it has to be after my PB&J experiment.
Okay.
All right, so George, grab a chair and pull on up.
Okay.
You got,
I got nothing.
but you know all of the names. We've done a bunch of snowball introductions.
No one's using their hand.
It doesn't matter. Pick somebody.
Command.
An algorithm is a command. Not enough information. Phone another friend.
Jason.
Jason. Where's Jason? Jason, what's an algorithm?
It tells
Tells you, no, I'm looking for more of a generic definition. It doesn't have to deal with computers. Andrew, what do you got? A series of instructions. If I could clarify that, it's a step-by-step series of instructions that involve a process or solve a problem. It just so happens that ultimately we'll be talking about algorithms and how they relate to computers. Today, the problem is how to build a peanut butter and jelly sandwich. All right? So to do that, the assignment that I gave you was we gave a small nod. We gave a small nod to the Java programming language. What was the nod to that? What's the only syntax I'm looking for?
Semicolon.
Semicolon. And what's important about a semicolon?
It ends every statement.
It ends a statement. Unlike the English language ends in a period, in Java, it all ends in a semicolon. Okay, so let's talk a little bit about how you wrote the rest of it. So, Noah, what is pseudocode?
It is using the English language to describe.
Perfect. Perfect. No, I like that a lot. Using the English language to describe code or describe a process. So you are using pseudocode to give a very stupid computer, because we had this conversation yesterday, right? We asked the question, are computers inherently smart or inherently dumb? And who remembers the answer, or what we arrived at?
They're dumb.
And why are they dumb?
Because they take everything literally.
They take, well, okay, so they're just a collection of transistors, plastic, metal pieces and parts, but it takes a program, it takes software, it takes an instruction set to make them smart. So for today's purposes, this is the only time during the year you will call Mr. Lee dumb. But per second period, I won't use the one that we talked about in here yesterday, but second period, I think it was Max, said computers are dumb as a rock. For our purposes, I am dumb as a rock today. Okay, so here we go. So I need a randomizing algorithm. Ethan, can you randomize the attempts that were made here?
All right. Just like pick one.
Well, mix them up a little bit because I don't know how they got handed in, and I need you to turn them over. And there's a couple of ground rules. So somebody will get selected to randomly pick one of the algorithms to build a peanut butter and jelly sandwich. However, when we pick it, if it's your algorithm, you are not allowed to be the compiler. You're not allowed to tell me the instructions. Oh, by the way, you're also not allowed to give hints or shout out, no, I meant to do this or that. I'm taking them literally, because Max said computers take literal instructions, and then we're going to pick somebody else to be, this is the vocab. So somebody doesn't know how to follow instructions. I've got a wonderful printed vocab in here with no name on it too. This is great. So you already lost 30% of your grade on that homework assignment. So we'll put that one aside. Okay, flip them upside down so you can't see. Maggie, would you honor us by randomly selecting an algorithm from the stack? Wonderful. Well done. Well done. So, Min. Min, are you feeling lucky? do you like peanut butter and jelly sandwiches? You don't?
No.
You don't like peanut butter?
I've never had one, to be completely honest. I
Don't
knock it till you try it, man.
This is like last period, so I had a student who never read Calvin and Hobbes, and now you've never had a peanut butter and jelly sandwich?
Don't knock it till you try it.
No idea what you're missing out on. Okay,
Probably
so,
not gonna end up with a good sandwich.
so here we go. So I need to pick somebody to be the compiler, and it can't be somebody who's done this before. You're sitting way too close to him. So
We're just gonna read it.
Jimmy is going to be my compiler. All right, so hold on. So here are the rules for a compiler. So what does a compiler do?
Make sure the program can run.
No, it reads the code to the computer.
Okay, so the compiler reads the source code, which ultimately gets translated through the compiler, down to bytecode, through assembly, and down to machine level language. What is machine level language?
1 and 0.
Ones and zeros, dynamite. And why are ones and zeros important?
Because it's what the computer can understand.
It's what the CPU processes. All right, so compiler. I'm dumb as a rock, just remember that, all right? So I need you to first, we're going to see if this program will compile properly. So, question, the class header. Can you read it out to me?
Public class build PB&J.
All right, and are the two first words, reserve words, all in lowercase? And the last word, is it in camel text? Is there a semicolon at the end? Good, because class headers don't end with semicolons, they're not statements. All right, can you read the inputs to me, please?
Jar jelly, jar PB&J, loaf bread, plate, knife.
Knife, okay, so far so good. Can you now scan all the instructions and tell me if each statement ends in a semicolon?
I forgot about the knife.
How do you forget about that?
Each statement must end in a semicolon, because that's what Java does. You're my compiler, yes or no? He's missing a couple? So what happens in Dr. Java when it doesn't compile? What happens?
Highlights it, rip it
It
out.
highlights everything and it's yellow. One down. Okay, Ragavi, please pick a program.
It's not really random. Well, you mix them up, so I know.
Whose program is it?
Taylor.
Taylor.
Oh, yes!
No, Taylor is disqualified because he's seen this before.
No, he hasn't.
Oh, he hasn't?
No,
Then you haven't spoken to anybody about this?
I gave.
I can already tell it's on one piece of paper, so this is going to go well. So, okay, so I'm going to pick Trent. Hey, Trent, will you be my compiler? All right, same shtick. What's the class header?
Public class build PB&J.
First two words are in lowercase.
Well, I guess.
Yes?
I can't tell.
You can't tell?
No.
That's not good, especially when you take tests in my class. That's not good.
That's a capital.
Everything's capitalized?
Well,
Is
it's
it?
capitalized, but I'm not sure because it's so small. It's like the same size as
Yeah, so on test, you cannot capitalize that P, that's a capital P. I'm going to let that one slide for now. All right, I need my inputs. Compiler, my inputs, please.
jar jelly. Actually, there's space in these. Is that?
What?
Yeah.
Let me see that.
Jar jelly and jar PB.
Are there?
No spaces are allowed. Okay, are we doing these in order? Okay, Ethan, feed me another one. Ooh, feed me. Jason Price. Have you seen this before?
No, never.
No, already.
Yeah.
No, yeah.
You've seen it before.
Already, no, yeah.
So we will come back. We will come back. Next. It doesn't count if you've seen the end. Maggie. Okay, so here you go, Caroline. You can read Maggie's. All right, what's the class header? Man, we haven't made it far at all.
Well, you disregarded mine.
Hush.
There's no semicolons anywhere. Yeah, I know.
So no semicolons?
Rip.
Guys.
It's all just
We're so bad.
I told you.
I love this.
Matt? Matt, where's Matt? Matt,
Oh, man.
you feeling confident?
Not really.
Not really. Not really. So we're going to ask who's a newbie. Ben, no, you sit next to Matt. Ragavi, you're going to be my compiler for this one. All right, Ragavi, can you read me the class header?
Public class build PBJ.
All right, and is it spelled correctly and under lowercase letter and all that stuff?
There's a space between build and PBJ.
Yeah.
All right, we're gonna let that slide because otherwise we're never gonna build a peanut butter jelly sandwich. Okay, can you read me the inputs, please?
Jar, jelly, jar, PB, loaf, bread, plate, knife.
Okay, can you now check that all statements end in a semicolon?
Well, okay, can I start with like numbers though? Like he numbered off.
He numbered the steps.
Yeah.
I'm going to let that slide because
Probably line
it's
numbers.
pseudocode, but
Yeah,
in the
line
Java
It's line
programming,
numbers, yeah.
yeah, so but in Java programming, you cannot start variable names or anything else with numeric values. But because it's pseudocode, we're good. Compiler's kind of slow.
Ouch.
He missed a few.
He missed a few.
Yeah.
What do you mean?
He forgot it.
Let's just let it slide, otherwise we're never gonna get there. Okay, can you read my first instruction, please?
Pick up the jar PB and
Pick up jar PB.
grasp the basin lid. Twist the lid off in a counterclockwise motion, making sure that the bottom of the jar stays in contact with the desk.
Oh, you told me to pick it up.
Release the jar PB and place the lid on the desk.
Oh no!
That's really not fair.
No!
No, that's because you've seen it before, so let me take care of it.
No, it was a new job.
That's not fair. Of course it's a new
Figure
jar.
that. Why they not paying this? I just like everything else.
We knew about
Okay,
Oh, I was so
okay.
scared.
We're gonna give him the benefit of that, that was me. But, good point. Okay, I'm sorry, go ahead.
Pick up the jar jelly and grasp the basin lid.
But you never said let go of the peanut butter.
Oh no!
Yeah, he said release the jar
Oh,
PB.
Oh, he did?
Yeah.
Oh, dumb as a rock computer missed that instruction. Okay. Pick up the jar jelly, grab basin lid.
Twist the lid off in a counterclockwise rotation, making sure that the bottom of the jar stays in contact with the desk.
You know which one? Is this one new?
Release the jar jelly
Okay, this one's not.
and place the lid on the desk.
Okay, by the way, this is pretty good so far, barring the fact you forgot your semicolons. But I want to talk about, did I just repeat an instruction and just did it with a different object, right?
Yeah.
Could have
So
just-
what is that called if we do that?
It's an action.
An action or a process? So I could basically say, do that process again, do it the first time with the peanut butter jar, do it again with the jelly jar. And that would be called reusing code. Ultimately, you'll be writing methods to do that. Fair enough? Addie, can I ask a big favor? Can you go push the space bar on my computer so we're not feeling like I got a black light on? Okay, compiler, what's my next instruction?
Untie the loaf of bread packaging and carefully grasp 2 pieces of bread
They didn't say how to. It's just
do it.
time.
Just do it.
This says untie. Come
It just says
on. Come
untie.
on. It said untie.
No, he
out of the
if he
container,
had
making
explained
sure
the
not
jar.
to change.
No, hold, slow down. I'm still at untie the,
Untie the loaf of bread.
How's it supposed to do it?
I don't know how to untie.
No PBJ.
I mean, I tie my shoes one way. This is tied a different way. If I had a bow tie, I would tie it something different.
We got it.
So,
Mistakes were made.
so again,
Compiling error.
a computer is dumb as a rock and it takes instructions literally. Alright? So, I mean, eventually we want to eat PB&J sandwiches, so you guys need to vote. Am I going to let that instruction slide and
Nope.
continue?
No,
or-
no.
No.
If you had to explain that twisting the jar, then the answer
Yeah.
You already got several freebies.
Yeah, he's already got a bunch of that.
You have to write semicolon after every
statement.
line or
Statement.
Every statement. Every statement.
There's a period
So
on point.
since you did so well, Matt, we're just going to leave that off to the side.
Don't you have to screw the
It remains.
Julie, don't you have to start over, like re-screw the jars?
Yes, I will do that. I will reset my program. Caroline, Bills is up. Caroline, do you like peanut butter or jelly sandwich?
Can I please come
I
back?
got two that don't like it.
Aria.
No, God, no, you've seen this before. Noah, you're up. Hold on, let me reset. Are you confident that you get further than that?
I think so.
Okay, good. Okay, let's do it again.
She wants to put a space there, but.
All right, what's the name of my class?
There are little boxes in the
The
table.
other space is like between public and class.
Okay, that's good.
Sorry.
We're good.
Public class build PBJ.
Good. Next line.
Wait, do I read this?
Yes, I need my inputs.
Totally a cat.
Because this is important. I can't run a program without the variables being declared.
Okay, declare variables. Jar jelly, jar PB, loaf bread, knife, plate.
Next.
All right.
Oh, are there semicolons at the end of all statements?
Nope, there's a period at the end of one.
What?
Period right there.
Oh, come on.
So you say, oh, come on, but when you compile Java programs, it's really, really picky. It's really picky, so you gotta remember that. Okay, should we let it slide?
But it does only have
What
once.
does mine get assigned then?
It is true.
I
that
don't
it does
know,
only
because
have
we're
once.
picking on you, man. All right, let's go.
These are first.
First instruction.
Face the table.
Which table? You shouldn't have put that.
Face the table.
Should I keep going?
Yes.
All right. Place left hand on the side of the jar PB container and grasp it lightly.
Next.
While holding the jar PB in your left hand, take your right hand and unscrew the lid counterclockwise.
This is biased to right-handed people.
Oh, okay.
It is.
Do I know what counterclockwise is? I'm going to give her the benefit of the doubt.
Well, how do you describe it counterclockwise?
Yeah, you can't say
I think it has to do with how the Earth rotates.
Put
Yeah, you wouldn't, the computer wouldn't know that. It
So
would at
put
least,
lid on.
at least
Screw
it's like a
left.
simplest screw.
Okay. Put jar PB on table and let go.
Ooh, hold it. You didn't talk to your big brother, did you?
No, I didn't.
Okay, promise?
I promise.
Okay, let's go. By the way, it's awesome having little sisters and little brothers in the class. All right, here we go.
All right. With your hands, untwist the twist tie on the bread package.
Did we miss something?
No.
No.
Sorry.
You be quiet. You're not my compiler.
Maybe it's coming.
All right, go ahead.
This is the next line.
With my what?
With your hands, untwist the twist tie on the bread package.
Untwist?
You know what?
Roll it out.
No.
What do you mean, no?
Let's
No, really.
untie, untwist is at least a little bit more specific. And I really want to get to the next level, so I'm going to let this one slide.
Well, at least let me know.
And no, I'm not giving favoritism to the girls in the class, even though girls rule and boys rule in computer science. But there you go. The twist is untwisted.
Okay.
Can you take a video?
Yes, absolutely. Just come on in.
Gently open the loaf bread container.
Gently open it.
Yes.
Oh, no.
No. There you go.
No!
So we got through with you.
He said gently, so
It was good while it lasted.
it was good while it lasted.
Okay, I think I'm good.
You too.
I would say gentle.
With your left hand, pull out and grasp one slice of bread.
Pull out and grasp it.
Wait.
Pull it out.
Oh, did it say lightly?
No, it just said grasp. All right.
Okay. let's-
think that's
Okay.
Okay. Use your right hand to gently lay the slice of bread in the center of your left palm. Keep that position.
What?
Oh, okay, this is. Okay.
All right. Next
It's a
page.
weird-
By the way, we're making progress, even though my bag of bread looks pretty bad.
That one's sliced. But why is it so? With your right hand, pick up the knife by its handle.
Oh, I'm
with the
glad you said by
blade
its handle.
facing the door.
Down.
Oh, sorry, facing the floor. Facing the floor.
Yeah, I guess like that.
Okay. While holding the knife, stick the nut. Wait, what? While holding the knife, stick the knife into the jar PB and put some peanut butter on it.
There's peanut butter on it.
There's peanut butter on it.
Take the knife out above the jar PB. Okay. Take the knife and evenly spread the peanut butter on the slice of bread in your left hand.
I don't know how to spread, but we're gonna go ahead and give her the benefit of the doubt. Yeah. Okay?
Alright.
I don't know how you would
With your left hand, put the slice of bread on the center of one plate.
Upside down.
Sitcom wah wah.
Dumb as a rock.
Trombone.
This project.
Ooh, sad
Alright.
trombone.
Set the knife down on the plate to the right of the slice of bread.
Again, she's a righty.
Place left hand on the side of the jar jelly that had it.
That's what it says.
Are you sure?
That's what it says.
Where?
Oh wait, and hold it.
Oh,
Sorry,
hold
that's a
it.
lot like
Yeah,
an
hold
A.
it. Yeah, it doesn't make
That looks a lot like an A. With your right hand, grasp the jar jelly lid and twist it counterclockwise. Alright, place jar jelly lid on the table. With the right hand, pick up the knife next to the bread slice by the handle, facing facing the blade towards the floor.
Oh, now he's here. Oh, I see.
No.
I know it's kind of it.
I keep losing my place. This is very difficult.
You're awful.
I really am. Alright. Put the knife in the jar jelly and get some jelly on it.
Okay, so by the way, for some people, this is the height of blasphemy to take the peanut butter covered knife and stick it in the jelly jar, but you know what?
Is by
Violation of PB&J rules.
If we had brought knife 2, he would have got a second one.
Man, I was decent. I added knife equals 0 after that.
With your knife equals 0.
Yeah, you clean the knife off.
Shut up.
Oh yeah, he has paper towels. He could totally clean it.
With your left hand, pick up the slice of bread on the plate and place it in the center of your palm with the peanut butter side facing up.
Oh.
I can do this.
Oh no.
Wait, so you just spread it onto the peanut butter?
Yeah, I don't build mine this way, but we'll go ahead with that. You said peanut butter, I'm sorry, I'm looking at you. Compiler, you said peanut butter up, correct?
Yes, I did.
All right.
She was actually specific about that, which is good. With the knife in your right hand, evenly spread the jelly on top of the peanut butter on this bread slice.
Who does a PB&J like this? This is
I've seen it. Wait, that's crazy.
One slice at a time.
All right.
That is kind of
Yeah,
weird.
evenly's tough with jelly. If it was jam,
You
we'd be in
put the-
better shape. Okay.
She better not
In the jar.
Alright, place knife in the center of the plate.
The center of the plate? Have it.
Yeah. Yep.
There you go.
Yeah.
With your
That's
right
pretty good.
With your right hand, grab one slice of bread from the loaf bread.
I'll be nice this time.
That's no fun.
Right. Place this slice of bread evenly on top. Wait, what? Place this slice of bread evenly on top of the slice in your left hand.
It says evenly.
Yeah.
So,
It did say evenly.
How
We got a sandwich.
Hold the sandwich with both hands.
Already done.
Please.
You guys ready for this next part?
Open your mouth.
Oh, I just said to build a peanut butter jelly sandwich.
Hey, it's not done.
Okay.
Compiler's still running.
Uh-oh. What did you just say?
I said compiler is still running.
Okay, fine.
Insert the sandwich in your mouth.
The whole thing.
explosion now. There's no swallow, it just says shit.
Mr. Lee, you're in an infinite loop.
Infinite loop.
I'm gonna move some milk.
He needs some milk.
Skip them all.
I'm having way too much fun.
Should I have paused?
Should I? Yes. No.
Okay, that's
the big one.
give me a second.
If we ignore the fact that you lost a semicolon.
We're still rolling.
One is enough to break broke the whole thing.
Okay, I admit, that was a first. They've never told me, you guys have never told me to eat before. Oh man, I really need a glass of milk now.
It's pretty. I didn't mix plus you.
All right, hold on. I mean, all right, so, Caroline, please stand.
Okay, but you lost a semicolon.
I know, but you know what? A warm round. Good. Okay. So I want you guys to be able to reap the benefits of a lesson plan like this. So we're going to create a production line for making PB&Js, knowing that Min has to have one first because he's never had one before. Or actually, Caroline should probably get it first. Oh, that's right. At any rate, the takeaways, besides me acting like a fool, that we want to remember are computers are inherently dumb. Programmers provide instructions that teach computers how to solve processes, algorithms, and when we're designing in the Java programming language, it's called object-oriented programming. And the idea is that it models the real world to solve a problem, and we're using technology to solve that problem. Which will lead into our demonstration at the end of class, because George, where'd you go, George? George is going to do a demo on behalf of the Robotics Club, because Robotics uses Java, the Java programming language, to provide instructions to the robot itself. So this was great. I'm just curious, a show of hands, who else thinks they might have actually, besides my repeat customers, who else thinks they might have gotten it? Okay.
Can you read the last two lines of my face?
Yeah, if you can find it. But I'm here. I'm gonna. So what time does class end? What does it say?
Place hand into jar PB. Remove hand from jar PB and smear on face.
Boy, I'm glad I didn't use it. At any rate, so what I would like to do is I've got paper plates, paper towels, and if we can set up an assembly line, somebody who wants to be my plate person, then I need a bread person, and then I need a PB person and a jelly person. We're just going to go down the line and they crank them out. I do want to share a couple of things. In past times, because nobody has been specific, nobody was specific prior to this, I've had somebody say,
Oh.
put hand on top of jar, and then
Open jar.
no, or open jar, which I don't know how to do. I had somebody say put knife in peanut butter, and I've actually put a knife through the peanut butter.
I thought that might happen.
I've had somebody forget to tell me to turn the top, so I've ended up spinning around. But the idea is we're having a lot of fun, but it's to make a point. And what do they say? You know, the human mind can retain about 10% of whatever they learn. My hope is that you may not remember everything about the Java programming language after a year of AP CompSci, but hopefully you'll never forget this. So thank you guys for participating, and to Miss Kennedy's class, a shout out to the broadcast and video production guys. So way to go, I appreciate it, and let's eat some PB&Js. Hold on, I've got a few more loaves of bread. I can't believe I only destroyed one loaf of bread though. Usually I destroy 5 or 6.
That's 9.
That is good.
You're not nearly this forgetful.
Yeah, I'm so proud of mine. Did you teach them how to make a PB&J?
So much work into it.
You can't make a PB&J yet.
Okay, Jason, you got another paper towel?
Yeah,
I rinsed it. I wanted to wash it off.
Hi there.
Eric, you want to throw it, right?
Oh, actually, if you guys will roll again for his robotics.
Oh, we already
I think
started.
that would be awesome.
Yeah, that's what we're doing right now.
Okay, so we're doing production line, and at the end, just start handing out PB&Js. By the way, I need a lot of help at the end of class. If you guys would help me make sure that all of the paper plates, any trash ends up in the trash can for me, I'd greatly appreciate it.
So, yeah, I sent all the code to his email address, so if you want to pull that up on the projector.
No, can I have that?
Oh, yeah, sorry.
Excellent job, by the way. All right. Hey, Jimmy, can you stack those neatly? Put them in order?
So, yeah, in order of best order.
And it'd be great if you could put them alphabetical order, but I'm fine with just face up and kind of in a neat stack. All right, George, so you've obviously got their attention. Tell them a little bit about the Robotics Club.
Yeah, so the Robotics Club, just every year we do 2 competitions where we build, we have to design an entire robot from scratch to complete some certain task. So, for example, this one was meant to do pull-ups. So if there's a solid bar here somewhere, it can do a pull-up from it.
Can you use an arm?
It's really heavy, but it could do it. I could use like a door handle or something like that. Anyway, so yeah, it's got like a hook on the end and everything, and it can, it's got a couple of other controls. So there's a couple of like game elements that go in there, and it pulls a pin to drop on something.
Oh, okay.
These
Sounds like a
also
little bell.
these also hit some triggers that are on the side of the ramp.
George, you created a suicide bomb.
I did. But so this is basically a mountain climbing kind of pull-up robot. We have to build a brand new one every single year, so it changes. And the game changes every year, so we have to come up with something new. And
So how heavy is he? Can you just do a pull-up on my arm?
here, yeah, you can probably do that. I don't know if the battery. Here, just kind of put your hand around the hook on top there. Do you see it?
Here?
Yeah, so much harder is for the killing than
So
I need to come bring him this way?
yeah, I can do that. Okay, so yeah, just kind of hold your arms up like this and kind of hold on to it. The battery voltage is really low, so it's gonna take some time to do this, but it can do it.
You want
Yeah.
down, you know.
Oh, the battery's dying, and so is Mr. Lee.
Yeah, you can put it down now.
Okay.
But you get the point. There's like a pull-up bar that it can do more pull-ups than I can.
Okay, and then talk a little bit about what instruction set makes this thing work.
So the instruction set that makes it work is called WPIlib, which is sort of a Java it's like a box of Legos for Java. So what makes both this robot and our much larger robots work is a sort of library for Java called WPIlib, which was made by Worcester Polytechnic. And it's sort of like just a whole bunch of commands that you can plug into a robot to tell it to do things. There's a bunch of different electronics that plug into a Android smartphone here that control lots of little different things like motor controllers, servo controllers, so we can run all the electronics on it. And so it makes it very easy to say, plug the phone into the power distributor, which gets plugged into a battery in all your devices, and say, I want this motor to run at 100%, right? That's very easy to do. Like, when I push the joystick forward, run the motor at 100%. You can actually pull up the code on your projector there, because I sent it to your email.
Oh, yeah. Sorry.
Should that be NP's one? Can anybody get it?
Yeah, you got the piece one.
And there's actually a whole bunch of sensors on this too that take input data and figure out some kind of output based on that. So
Hey, get us done.
one of the there's 3 sensors on this that are really important for what we do. One of them is a gyroscope, which takes constant data input, and that's located right here on the bottom. We also have an ultrasonic sensor pointed right at the ground here, so it can tell when there's nothing underneath.
Now it's bad.
And There's one other sensor. It's a.
Are you enjoying that one?
We used to have an
Like,
optical
hung on
sensor
that.
on here, but we actually opted to just use the camera because you have to like figure out different colors on the thing. Push a button.
You put like all the jelly on.
Anyone want one?
So yeah, there's just a bunch of data input. So here on the.
Hey guys, just listen up a sec. So this is actually Java code that's actually doing a real world thing with the computer. So I'm just going to, if you'll pan around, AJ. I'm just going to scroll.
Oh, right.
So notice there's a package. We won't be working with packages in the Java programming language, but the import statement we'll be working on. And then notice there's a class header. And I'm not going to talk about what extends does, but it's obviously...
So this is initializing the gyroscope. So this gives you like a whole bunch of input data that you can use to figure out the gyroscope's position in space. So yeah, there's a whole bunch of different variables we added in here. And these are our motor objects, so we can set voltage inputs to those. There's some other things here. This is all the... we call it teleop mode, which is sort of like a remote controlled mode for the robot. So whenever you have controllers and you do inputs, this processes it and makes all the motors and servos and everything do stuff based on those controller inputs. So for example, let's see right here. So we have a motor on the right side that controls the right side track. So we're going to say motor right is hardware map DC motor because it's a DC direct current motor. And we're going to get a motor in the map that's named motor right because you set it on the phone what your motors are named. Let's see if we can find another thing that says where to. Let's see.
Yeah.
Yeah, right here. So here's another method that we use called set drive power. And so left power is another variable somewhere that is just directly taken from the input number on one of the joysticks. So we're going to say set the power, which is like just number of volts, and we do some other stuff with it. So, and then here's your range. So you can go from -1 to 1. Like -1 is fully backwards, +1 is fully forwards. And this is all Java code, so it's all written in the Java programming language. And there's actually another application that's fully autonomous where it takes a bunch of input and can run itself and do different things.
Cool.
And that's another.
And again, you want to just give a pitch for the club itself?
Oh yeah. So we meet on after school Tuesdays and Thursdays. I won't be there because I have cross-country practice to do, but we do meet every single Tuesday and Thursday nowadays. And second semester we meet every single day because that's when our bigger competition starts. You don't have to have any experience to do it. None of us had any experience when we started because this is something you can't really do in middle school. And we would love to see more of you come here and use whatever you learn in this class or in Mr. Bishop's engineering classes or just on your own. We would love it if you showed up and could help out or find something new to do, or like Scott showed up once.
And George, can you tell them a little bit about the competitions that you guys attend?
Yep. So there's 2 competitions that we attend. There's actually a couple more in between. They use the same robots. One's called FTC, which stands for First Tech Challenge, and the other one's called FRC, which stands for First Robotics Competition. FTC is like these robots. It's 18 by 18 by 18 cube, and that's the maximum size your robot can be in the starting configuration. And it's played on a field that's about the size of that table except square. And it changes every year. So you have to build a whole new robot from scratch to score as many points in the game. The other one, FRC, is much more serious. There's like professional teams that do it. Like NASA has a team, for example. They're much larger robots, and I don't have it here, obviously, because it'd be kind of hard to get down here. But it's a robot about a little bit bigger than this cart. And it was, here, I'll pull this up. It's about as large as this. And that robot was designed to go over different obstacles and shoot balls into basically basketball goals, which was really hard to do, and we didn't do that well, but we were kind of short-handed. So that competition is worldwide. This FTC is just the United States, but there's teams from like Israel and Germany and Sweden and everywhere else that do FRC. It's like a whole worldwide competition. The new FTC game comes out in, let's see, it comes out in about 3 weeks. So we'll be getting to work on that and having to design a whole new robot to solve whatever challenges they give us. FRC comes out in January, so we're gonna have to wait a while on that one. But all in all, we would, if you're interested in this, we would love to see you after school, so you can, sort of get your hands into the world of robotics. It's very interesting stuff. And if you like Java, if you like programming, that's one thing that would certainly carry over to that. One other thing is, you usually don't think of like doing something like, I don't know, like, if you're gonna do fencing in high school, for example, chances are you're probably not gonna become a professional fencer, like an Olympic class fencer that makes millions of dollars off of fencing. But with robotics, to the competitions, all these big companies, General Electric, Lockheed Martin, Automation Direct, they show up to these competitions with these big booths handing out free stuff. Because they're not there to just give you free stuff. They're there because they want you to work for them. Because this stuff carries over so well to the real world applications. Team organization, design, strategy, materials handling, all that. It's all right there. And also there are millions and millions of dollars of scholarships that just go completely unapplied for because I guess people don't know they exist, so there's also that. And this looks amazing on college resumes. Just putting that out there. If they see, hey, you did robotics, that's like a shoo-in for a ton of places. Yeah, that's pretty much it.
Cool. All right. Thank you, George. Appreciate it.